Hi, and welcome to this video taking you through how Aviatrix can help you reduce cost and improve security by replacing first-party NAT gateways. Many of our customers depend on NAT gateways for private workloads that need internet access under specific circumstances. Typically this may be patching, operating systems, or accessing company code and image repositories. Whilst NAT gateways do solve an immediate problem for developers, their use may not be in the best interest of the company. Cost may be one issue, but most likely the lack of security policy will have CISOs concerned about vectors of attack, increasing the attack surface and general risk. Aviatrix provides a solution offering developers all the benefits of NAT gateways minus the unpredictable cost, whilst offering CISOs an opportunity to address their security concerns. This video will walk you through a typical customer deployment. We'll review a redundant application deployed across two AZs in AWS. Next, we'll show you how to deploy an Aviatrix gateway in a low-friction deployment with just a few clicks and zero impact. We'll then begin by taking over the NAT part of the equation from the CSP NAT gateways. Next up, we'll add a security policy to these outbound flows to the internet to meet your business outcome. This will then be strengthened to catch any non-web-based traffic, such as command and control operating over uncommon ports. We'll then integrate a SIEM for off-platform logging, and finally we will productionize our solution by adding resiliency. To summarize, we will deploy with zero friction, little to no production impact, lower cost, greatly improve security posture. Let's get started. Our environment consists of two workloads running in the same AWS VPC in each of these two tabs. This workload is running in AZ1. Each workload is running connectivity tests to a number of different destinations, internet-based destinations and some malicious destination. You'll see here many well-known URLs. And on this side, you can see the current status of the connection test. Manually refreshing the page will pull in the latest results. Switching over here, you can see this workload is an AZ2 and running the same checks as workload 1, internet and threats. Refreshing the page here also pulls in the latest results, and you can see all services are up. Let's deploy an Aviatrix gateway in this VPC with zero impact. This is Copilot, and you can see I have one AWS region where my Copilot is deployed. Let's switch to the topology view where you can see this Copilot deployment in more detail. You'll notice no other Aviatrix gateways deployed when you switch to the Gateways menu. Let's add a spoke gateway to the workload VPC. We'll begin by giving it a name. AWS is already selected here. I choose my AWS account, where the workloads are, the region, the VPC, the instance size. T3 medium will be enough to begin with. And let's leave the other settings as they are. We will deploy one instance in subnet, in the public subnet of AZ2A. I will pause the recording here for the time it takes for the gateway to deploy, which is normally 5 to 10 minutes. And this is a zero impact on our production workloads. Our gateway is now up and available, as can be seen by the green arrow icon. I can see the VPC CIDR range and the public IP address of the Aviatrix gateway. Clicking on the gateway will drop you down into another menu context. Attachments will be empty, as I'm not connecting back to an Aviatrix backbone in this use case. Clicking on the VPC VNet rod tables pulls in the rod tables from the CSP itself, so you don't need to log into a portal to find this information. The first rod table in the drop-down is a private subnet where our workload is deployed, and we see that the next hop to the internet is a NAT gateway. As you can see, we have not manipulated or changed any CSP rod tables yet. Clicking on the drop-down will allow you to select the other rod tables. The second private subnet shows the second NAT gateway, and the public subnets are leveraging an IGW. Gateway routes are routes local to the Aviatrix spoke gateway. Interface stats can be useful for troubleshooting, as can be the performance tab when knowing how and when to right size your instance. Route DB is empty as I have no external peerings, and settings is where we'll make the modifications later to take over the NAT function. Before we do that, let's check how our workloads are doing. These are both still using the CSP NAT gateways. As we can see, both are still working fine. And we can verify that they are indeed using the NAT gateways on the VPC VNet route table tab. Let's now go to the settings that I mentioned before and click on the NAT options. Here we will activate source NAT for the gateway. This is the point where we will actively modify the CSP route tables to no longer use the NAT gateways as next hop, but rather use the Aviatrix gateway. This is completed when the radio button is no longer grayed out. Let's jump across to our workloads. Now we may drop 1 or 2 packets during the change, and depending on where these packets were in the TCP flow, we may drop a session. But as you can see, many sessions didn't experience any interruption at all. Now let's check our VPC route tables to verify the change. As you can see, for the private subnets, the Aviatrix instance, denoted by an I, is now the next hop for the internet. Same instance in the second private subnet, and the public route tables are still using the IGW. So the most intrusive change is done, and our developers have the same experience as before at a potentially lower cost point. And as you can see, our workloads are doing very well. Let's jump into the security side of things and click on the Distributed Cloud Firewall menu to see the default rule base, which has an explicit allow for the time being. Our workloads have free access to the internet, but we want to discover what exactly they're connecting to so we can create a security policy. Let's build a discovery rule. We'll call it monitor. And select from anywhere to the public internet for all web traffic. We do want to log this rule and permit it. We'll place it at the top of the rule base. Now at this point, we still need to commit the change for it to take effect. As it's a permit rule, it has no impact on our workloads. Now going back to our rule base, we can see that traffic is hitting the rule by refreshing the counters. We can use the monitor tab to see the logging. We see which rules get hit and much of the expected detail you need from a security perspective. For our purposes, let's switch to the egress tab and see what web traffic is flowing through. We'll look at this over the past 15 minutes, and you can refresh this as you see fit. You'll get more friendly insights here into which web destinations your workloads are reaching out to, as well as the source workload information themselves. Once again, our workloads are not impacted by what we are doing. Now, by having our traffic flow through the Aviatrix gateways, we also start to build out net flow insights into our flows. Again, you can customize the times and see the most recent information. Switching to the Flows tab gives even more visualization. Let's jump to the topology view. We can see our topology view building out. We can see our spoke gateway, subnets that are deployed, and the workloads themselves in that VPC. Clicking on one of our workload icons gives us a great amount of metadata on the workload itself that I don't need to go to the CSP portal to find. Now, clicking on the Aviatrix icon, we see more of this metadata, but we get some additional troubleshooting tools at the bottom. Let's have a look here at the active sessions going through this gateway. Now, once again, you can see that none of what we are doing is impacting the workloads themselves. Now, the question is, what should these workloads be communicating with over the internet? Let's refresh our egress data, and we've decided that these two destinations are approved. That's Ubuntu and GitHub. Now, before we create an enforcement rule, let's clean up our rule base by deleting the monitor rule that we no longer need. And once again, due diligently checking our workloads, and none of this has been impacted. Now we know which URLs to allow. Let's begin by creating a web group, which is a container for this information. We'll call it whitelist and add both the top level domain and a wildcard for the subdomains. This web group will be referenced in our enforcement rule. You can create different web groups for different logical groupings as you see fit. Now that it's created, let's jump over to the rules to actually create a rule. Click on Add Rule. Let's give it a name. Select from anywhere to any web destination. And now we'll select the web group that we just created. Log and place it at the top. Let's commit the change, and we don't expect any impact as this is an allow rule. Now let's create a second rule to drop all other traffic. Web traffic, I should be explicit. Let's give it a name, and this time it's a catch-all, which will drop all other web-bound traffic to the internet. Now let's log it. It's going to be a deny. And we will place it just below the whitelisting rule that we created. Now we should start to see some impact on our workloads. As you can see, all web-bound traffic, except the whitelisted destinations, are not blocked. However, our work is not over just yet. What about non-HTTP and HTTPS flows, or flows not referencing a URL? Like this malicious flow, which is actually an ICMP exchange with a known bad actor. Let's create another rule to clean up this traffic, with a permit to begin with so we can analyze. Let's give it a name. And again, it's a catch-all for any internet traffic. Let's log it. And let's place it below the web blocking rule. So now we have a whitelist, block all web, and then permit everything else so we can analyze. Let's commit the change. Now we should see no impact as it's an allow rule. Now we got to go to the Monitor tab and filter on the rule name. We can now see what type of traffic this is and correctly identify it as malicious. And you can see this is the destination IP address referenced in the workload. Now the only thing we have to do is actually flip this rule from a permit to a deny in order to update and enforce our policy. Committed, and moving back to our workloads, we should see this slowly getting dropped. Here we see it starting to drop, which is the expected behavior. Let's jump back across afterwards to our log monitoring and verify that this is indeed the desired behavior. And now we can see that that traffic is indeed being denied. Now our workload behavior is as we expect it to be from a security perspective. We only have access to predefined and whitelisted destinations. Next comes the security lifecycle side of things and monitoring logs. Copilot has a relatively complete suite of logging tools, but many customers wish to send their logs to a third-party SIEM tools, and we support this. In our example, let's send our logs to Azure Sentinel. I won't go into too many details here on this, but just to show you that we can query Aviatrix logs in Sentinel. For example, this is all logs hitting our policy. If I modify the query, we can see drop packets. Let's finish up by adding some resiliency. As you can see, we have workloads in 2 AZs, but only one Aviatrix gateway. This can be verified by going to the VPC VNet route tables. And as you can see, for both of the private route tables, we're pointing to the same Aviatrix instance. So let's add a second gateway for redundancy. It's very simple and non-impacting. Let's edit the existing gateway and add a second instance in the other AZ. There will be no impact on our workloads until the second gateway is fully up and ready to pass traffic. We can check the status of the deployment by checking the running tasks. Now this whole process can take around 5 to 10 minutes. And again, during this time, there is no impact to our workloads at all. Now we can see the progress of this. And again, this is a very verbose way of looking at the different tasks that we're doing behind the scenes to actually go and deploy this second gateway. Once the gateway has become fully initialized and ready to accept traffic, only at that point will we do an API call to the CSP and modify the rod table for the AZ where the second workload is. So now we should see each rod table pointing to a different instance ID. So we can see this one here. Let's go to 2A. And we can see that there has been no impact to the workloads at all during this time. No impact. So what we've done here is basically finished our deployment by adding resiliency so that if one gateway goes down, Aviatrix will automatically modify the rod table of the other instances so that they point to the currently up gateway. So that takes us to the end of our video where we have deployed some secure egress gateways to replace the CSP specific NAT gateways. If there's any part of the video where you want some more information, please drop a note in the comments below. Thank you.